Okay everyone, we're going to look at our first lesson here on Intro to Expressions, and today we're going to focus on evaluating expressions and everything that kind of goes in with that. And so just as we get started, as you all see the vocab words that you need to get down, go ahead and pause the video and write down the definition of variable and algebraic expression, and then once you pick back up, I'll explain a little bit about these. Okay, so a variable, that is a symbol, and it's usually a letter, and it represents some unknown quantity. And so most of the time we use x as our variable here, but it can be any letter that we use. You're going to see x, you're going to see m, n, y, z, a, b, c. All those different letters are going to be used as a variable, but a variable represents something that we don't know. And as we're going to see it with expressions, they're going to continue to be unknown quantities. An algebraic expression. So an algebraic expression, it is an expression that contains variables, numbers, and at least one operation. So some things that are expressions. An algebraic expression, one example would be x plus 3. That contains a variable, a number, and one operation, the plus sign. Another one we could use would be y minus 4. It contains a variable, a number, and an operation, or 4 minus y. What about 2x? Would that be an algebraic expression? Well, the answer is yes, it would be. Okay, because remember, if there is nothing in between two things, remember that means we are multiplying. And so this contains a letter, a number, a variable, and the operation would be multiplication. And then division with expressions, division would be usually written as a fraction. So this is x divided by 2. Those are all expressions. A couple examples of things that are not expressions would be 2. Doesn't have a variable and it doesn't have an operation. Another example of something that would not be an expression would be 4. So just a number, not an expression. Now, if we had x, just x, is that an expression or is that not an expression? Well, if we just look at x, think about it has a variable. Does it have a number? Well, it does have a number. Anytime you just see x, that would be if we were to say it's 2. We said it's 2, but we could write it as 2 over 1, so it really could look like a fraction. If we just have x or a variable, really instead of x, it's 1x. Well, 1x means we've got a number, we've got a variable, and we have an operation, because x, or 1x, is 1 times x. And so this would be an expression. Okay, so there's some examples of algebraic expressions. Variables, numbers, and at least one operation. Okay, so that's what we're going to be dealing with today. So when evaluating an expression, we're going to be given the value of that variable. So they are going to tell us x equals 4, or y equals negative 2. And so the first thing that we're going to do is plug in the number for that variable. So if x equals 4, we would plug 4 in every time we see x. And then step 2, we're going to follow order of operations. So remember, we're going to multiply, divide first, and then we add or subtract, and then we go in order from left to right. And then our answer should end up being just one number. It's not going to be x equals this number or y equals this number, because we already know what x and y are in these expressions. So it's just going to be the number. That's all our answer is going to be. So if you need to pause to finish getting this down, you can. We're going to look at our first example now. So evaluate this example, and on your paper you should see it. 2 parentheses n plus 3 if n equals negative 4. So every time we see n, we're going to replace that with negative 4. So we're going to rewrite the expression first and put negative 4 in place of n. Now we follow order of operations. So negative 4 plus 3 is first. That gives us negative 1. And we're still in parentheses, and the 2 is on the outside of the parentheses. Nothing in between these two, we're going to do multiplication. So 2 times -1 would be -2. And -2 is just our answer. So notice I don't say n equals -2 or x equals -2 because we already know that n is -4. We don't need to say that n is -2 as well. It's just -2. That's our answer. Okay, so we don't have to do anything regarding that. We just say our answer is -2. So let's look at our next example. We've got w, which is 5, and v, which is 3. So we're going to plug in 5 for w and 3 for v. So 8w would be replaced with 8 times 5 minus 2 times v, or 2 times 3. And then we go ahead and do 8 times 5, which would be 40, minus 6, 2 times 3, 40 minus 6 is 34. So that is our answer for that. So it would just be 34. Once we evaluate that expression, that's the answer that we get. All right, so you all pause the video. I want you to answer these two. Follow order of operations, plug in the answers. Pause your video and answer those two. All right, so let's look at our first one. 4y squared plus 2 if y equals 3. Okay, so we're going to plug in 3 for y. It's going to become 4 times 3 squared plus 2. So next, remember, order of operations. Before we can do 4 times 3, what comes before multiplication? Exponents. And we have an exponent there. And so 3 squared comes before we multiply it by 4. So you got to do exponents first. So 3 squared, 3 times 3 is 9. So replace that 3 squared with 9. And then we do 4 times 9, which would be 36. So 36 plus 2, which gives us 38. 38 for our first one, okay? And then we've got 3m squared. M is -3, so plug -3 in for m, plus 2n to the third power, and n equals 2. So 2 parentheses 2 cubed. Do exponents first, so we're going to wait and multiply by the 3 and the 2. We're going to do -3 squared. Now, -3 squared, -3 times itself. Well, negative times a negative would be a positive 9. It's going to be 3 times positive 9. And then 2 to the third power. Remember, 2 cubed, 2 to the third power, is not 2 times 3. It's 2 times 2 times 2. So 2 times 2 is 4. 4 times 2 would be 8. So 3 times 9 plus 2 times 8. 3 times 9 gets us 27. Plus 2 times 8 would be 16. And 27 plus 16 would be 43. So our answer would be 43. Okay. So our next one here, sometimes they're going to give us an example of a word problem. They give us the expression, and we have to plug in the number they give us for that letter, which is A, and then we'll solve this expression. So athletic trainers use that formula, which is given right here, where A is a person's age. They find their minimum training heart rate. So find Latrina's minimum training heart rate if she is 15 years old. So A is someone's age. Latrina is 15. We're going to plug in 15 for A. And so 3 parentheses 220 minus 15 over 5. Now, anytime we have a division problem or a fraction, we need to get one number on the top, one number on the bottom, and then we can divide. And so we're going to do everything on top first. So 220 minus 15 would give us 205 over 5. Next thing, we need one number on top, not 2. So 3 times 205 is going to be 615 over 5. So 615 over 5. And then the last thing we can do is 615 divided by 5. And that will give us 123. So her minimum training heart rate is 123. Okay, so one thing that I want you all to do next is pause the video, and I want you to find your minimum training heart rate. So you're going to take your age, 11, 12, 13, plug it in for A, and tell me what your minimum training heart rate is. So go ahead and do that, pause the video, take a couple minutes and find what your heart rate is. Okay, you should have gotten a decimal for yours. Whatever you did, I can't tell you what your number should have been because it's dependent on your age, but hopefully you were able to get somewhere around 121, 122, somewhere around there. Okay, so then last is this next example, the formula for turning a Fahrenheit temperature into Celsius. And this is the actual formula to go from Fahrenheit to Celsius. And so we're going to plug F in. What F is going to be is the temperature in Fahrenheit, and that's going to spit out or give us what temperature that is Celsius. And so we're going to plug in 77 for F, and so 5 parentheses 77 minus 32 over 9. So we're going to see what 77 degrees Fahrenheit is what temperature Celsius. That's what we're going to look for. So first do 77 minus 32. And that's going to be 45. And then we can do 5 times 45 before we divide all of that by 9. So 45 times 5 would be 225. 225 over 9. And then we do 225 divided by 9, which is going to be 25. So 25 degrees Celsius is 77 degrees Fahrenheit. So we're just taking the number that they give us for F, and we've just got to know that F stands for Fahrenheit, and plug that in, and then finish evaluating that expression. Okay, so now that you have seen what all they give you, you can go and answer the questions that are in your book. So go ahead and work on those.